Welcome to another Hopper language video. This is a general language video that should apply to all platforms. If you're not familiar with Hopper yet, I suggest looking at some of the more general videos on my channel before looking at the languages videos. Anyway, this video is about the delegate feature. And I'm going to use the Hopper editor as my sample app to illustrate what it's about. So in a very meta way, we're going to use the editor to edit the editor. Okay, so if I'm in the editor and I look at the menu here, undo and redo are disabled. However, if I delete something and then I go back, now suddenly undo is enabled. So I can click on undo, it comes back. I go back, redo is enabled, undo is not enabled. How does that work? Let's go find out. If we go and look in commands, which is how things are hooked up to the menu, there's these things called delegates. Two delegates that are specific that we're going to look at today are execute and enabled. Enabled is the one that tells it when to turn that on and off. And delegates are Hopper's version of function pointers that you would imagine in C. But function pointers are pretty dangerous. They give you enough, rope to shoot yourself in the foot. In the more modern languages like C# and Java, you have type-safe delegates. So you have a function pointer which has a type to it. So these delegates, these take no arguments. The enabled one returns a Boolean. The execute returns nothing. That's Hopper for void. There's no void. It's nothing. So let's go and have a look at the build command and see how these delegates are used. Let's remember we've got command execute delegate and command enable delegate. So if we go to the build command and we scroll down, we're registering some delegates with the menus. So for here again, enabled, so the run option on the build menu is not available because it hasn't been compiled. Actually, it has been compiled. It knows that it's current, so I can actually run it right now. So how does that work? Well, the menu is calling this run enabled method via this hookup through the delegate, which is type-based. So we can go and have a look at that. So it means that, and it's registering that onto the menu at this run thing here, this run enabled. So we can go and have a look at can run. Let's go and have a look at can run. So how does can run do? Well, there's some comments about it, but I can explain it. Gets the binary path for this program, takes that from the main file of the first thing I edited, and it goes and looks in the binary folder for edit.exe. If it exists, yeah, we're looking good. We can probably run it if it exists. Then if there's nothing in the undo buffer, well, that's interesting. So if I delete this word, now we have something in the undo buffer. If I go to, I can't run it anymore. So it doesn't start without debugger says, no, you can't. If I undo, I can run again. And the reason why it says start without debugger is because this is on Windows and I only have a 6502 debugger. I don't have a debugger on Windows. So anyway, one more thing in this. Okay, there's no undo I can run. What else do I want to check? Is it younger than the source? So there's something that's comparing timestamps on files between all the source code for this project, not just this file, but all the source code for this project, and the timestamp on the executable. And then this returns true or false as per the delegate. So the delegate said no arguments and a true or false return. Anyway, that's how delegates work. And then the sample I've been working through recently is this 6502 tiny basic sample. So let's have a look at that. Gibble. Gibble uses delegates too. How does it use delegates? Well, Gibble generates machine code, Hopper virtual machines codes. And if we look at negate, let's look at div 0, divide by 0. Oops. So it's got a division by zero check that it uses for if it does division or modulus. And it generates some opcodes here. And then if it fails with the division by zero error, here it says like, duplicate what's on the stack, jump if not zero, an offset of 8 forward, which takes it past all this and carry on with the program. If it is 0, it pushes error number 16, which means division by 0, and calls this error function and then exits the program. So this error function is what we're interested in. What's error pointer? Let's go back to Gibble and have a look at the runtime library for Gibble and look for error pointer. And there it is. Error pointer is a runtime error delegate. So the definition of the runtime error delegate is over here. Takes a number as an argument, which we did. We called it with error 14, I think it was. And it has no return value, void return value. So that's the definition of it. So we can assign this to any function that has the same signature, and it will compile. If it doesn't have the same signature, it won't compile. So which has it been assigned to? It's been assigned to error. And it's lowercase because it's private. It's a private method. Uppercase E would be public. That's a Hopper convention. Private is lowercase. So this gets used by a lot of things by the look of it. And there's the definition. So it's taking in the number, which is the error number, and then it's calling another method out in public to do the error, and then it's returning back to that machine code. So just for interest, I can actually show what that error looks like, what that error code looks like too. It's very boring in terms of just to switch with all the errors. But that's, if it's terse, it doesn't, if we're trying to save space, it only puts the number out, not the message, because here's the error. Well, there's multiple overloads for error depending on whether you have a line number or not when you're compiling, and smaller ones, simpler ones. And if it's terse, it won't print the message. It'll just say the line number and the error number. Anyway, I think that's a good example to show how delegates can get used. So either I use them to do the menu callbacks, and we use them to call back out of the code that's executing for BASIC to call methods that have been written in Hopper, like this error method is written in Hopper. It would be a bit of a bind to have to write all that in assembler, just because you want an error message to come out. So that's the main purpose of delegates, is to call back at runtime to something that's a little more complicated than, or a little more generic than just a function call. Thank you for watching.